Hey everyone, welcome back, and today let's solve Leetcode problem 2554 titled Maximum Number of Integers to Choose from a Range 1. So we're given an integer array band and two integers n and max sum. So we're choosing some number of integers following the below rules. So the chosen integers have to be in the range from 1 to n inclusive. And each integer can be chosen at most once. Okay, so the chosen integers should not be in the array band, which is another parameter input that we're given in this problem, right? It's going to be in the form of an array of elements that we cannot choose in this range to actually sum up, and the sum of the chosen integers should not exceed the max sum. So we need to return the maximum or the most number of integers that we can actually choose following these maintained or mentioned rules. So in example 1, we have our input array band to be 1, 6, and 5, n to be equal to 5, and the max sum to be equal to 6. So what this is really telling us is that we need to choose numbers in the range from 1 to n, or 1 to 5 in this case, exclusive, or rather inclusive, sorry, that are effectively the sum of the elements that we actually choose should never exceed 6. In this case, that's max sum, and we can only choose these elements as long as they're not part of this band array. Okay, well, one observation that you should probably make is that there's no point in choosing larger elements, because at the end of the day, that's going to give us a larger sum, and that's going to minimize the number of elements that we can actually choose. We want to choose the smallest integer possible at each step, so we can maximize the number of integers we choose without actually exceeding the maximum sum, right? Because we want to have the smallest sum possible with the most number of integers that we actually can choose until we actually exceed this maximum sum in this range of 1 to n. And that this is actually displayed pretty clearly in this example 1 as well. Right? We can choose the integers 2 and 4 in this problem. The reason why is because 2 and 4 are both in the range of 1 to 5, and their sum is less than or equal to the maximum, which is 6, and 2 and 4 are both not in the band array. We can use them. 2 is not in this band, and neither is 4, right? And effectively, their sum is 6. That did not exceed max sum, and so 2 is the maximum number of integers that we can choose. Well, what's another alternative here? Well, really, there's not really much of an alternative. I guess theoretically we could choose only 2 or only 4, but that wouldn't really do anything, right? And we could also go with 2 and 3. That's also one more alternative, right? If we choose two elements, 2 and 3, that's still in the range. It's not in band, and it still has a sum that's less than max sum. But regardless of what combination we choose here, we're not going to exceed the maximum sum of 6, right? We can choose at most 2 elements. Either we can be 2 and 3, either it can be 2 and 4. Right, because those are the only two elements in this range that are not in band that have a sum that's less than or equal to max sum. It doesn't exceed this max sum input. So in example 2, we have our input array band to be 1, 2, 3, 4, 5, 6, 7, and n to be equal to 8. And we have our max sum, in this case, to be 1. Well, in this case, we have to output 0, because first of all, we have to choose elements only in the range from 1 to 8. But the numbers from 1 through 7 are in our band array. We can't choose any of those numbers, and we have a max sum to be 1. So the only possible number that we can choose, in this case that's 8, because it's the only number in the range of 1 to 8 that's not in band, that already has a sum itself that's greater than max sum. So we cannot choose any integer that's actually maintaining this problem's constraints to actually follow this problem's rules. And so for that reason, we have to output 0. And finally, in example 3, we have band to be an input array of length 1. It has 11, n to be equal to 7, and our max sum to be equal to 50. So essentially what that's saying is that we effectively have to, again, choose numbers in the range of 1 to 7 that are not in band and that have an overall sum or total sum that's less than or equal to this max sum of 50. In this case, our output is 7. And the reason why is because we can choose all the integers from 1 through 7, right? 1, 2, 3, 4, 5, 6, and 7. If we do this, we're going to get a sum of 28, and that does not exceed the max sum of 50. And neither of these elements are in our band array. Well, you might be thinking, okay, well, neither is 8, 9, or 10. And If we add like an 8 or 9, that we still wouldn't exceed 50, and 8 and 9 are both also not in band. So why can't we choose that? Well, that's because n here is telling us that we can only choose numbers in the range from 1 to 7. 8, 9, and 10 aren't values in that range. So we're already capped out when we choose 1 through 7. That's the maximum sum that we can possibly get that doesn't exceed max sum, and that's also the maximum number of integers that we can actually choose to follow this problem's constraints that are not in band. So with these problem statements out of the way, I will give you guys a few seconds. I'm going to just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so going back to that initial observation that we actually made here, we want to choose the smallest integers possible in this range, right, that are not actually in band, right? Because what that's doing is that it maximizes the number of integers we have, because it makes sure that we have the smallest possible sum at each step, so we can choose more and more integers without actually exceeding our max sum input. So I'm going to comment this out here. We want to choose smallest possible numbers in the given range that are not in the band input array. And an easy way to do this is also to keep track of a current sum, and we just keep adding the current element to that sum while it's actually less than or equal to the max sum, and if it's not in band. Okay, so we're going to keep track of a running sum to make sure that the current sum of all the elements that we choose are not actually exceeding the max sum once we actually add that element to it, and that element is not actually in band. And believe it or not, that's really the entirety of this problem here. So I'm going to actually convert my band set into my band input array to actually be a set. And the reason why I'm going to do this is because, first of all, we don't care if we have duplicate band values in our band input array. We only care if it's in the input array or not. Okay, so this is going to remove all the duplicates, but more importantly, what we really want is that we want a constant lookup time to optimize our solution, right? Sets and hash maps have big O of 1 or constant time lookup times, which is another reason why they're very, very important and useful data structures, right? And so converting this to a set is going to give us a constant lookup time, and it's going to optimize our actual code, right? It's going to have a quick lookup time, and it's going to avoid any potential performance issues and slow runtime that we could potentially encounter, right? So once I've done this, now I want to actually initialize my variables, basically the current sum, the running sum that we're adding elements to, and the count of the number of elements that we're actually choosing that don't exceed our max sum total sum, and that also aren't in band. So I'm going to have a current sum, and I'll just call it current sum for understandability, and I'm going to initialize this to be 0 because we haven't actually added any sums, because we haven't actually traversed through our input band yet. Now let's actually loop through 1 to n, right? Now let's actually loop through the range of numbers that we could possibly choose from. So for I in the range of 1 to n, in this case I'm going to do 1 to n plus 1, because in Python here, for loops here are actually exclusive for the second and third optional parameters. So for I in the range of 1 up until n, this is simply the range of different elements that we can choose from that aren't in band, while that current sum is actually less than the max sum. So for I in the range of 1 till n plus 1, for this current element in this iteration, in this range, if I is in the band set, in other words, if it's band, then we immediately want to just continue. We don't want to use it because, of course, we're not allowed to use it, right? We're not allowed to use it, and so we just have to continue on to the next iteration if it's in the band set, right? That's the whole use of this band data structure input. Now, if it's not in the band set, then we want to check, well, is the current sum, basically the current running sum of all the elements that we've added at this iteration so far, if current sum plus this current element I that we're actually planning to add, as long as it's greater, or rather as long as it's less than k, we can actually add it. But what if it's greater than k? If after we add this element in this iteration to our current running sum, to our current sum, if that's greater than k, if it exceeds our max sum input here, then we know that we're in a problem, right? And sorry, this should be max sum. I don't know why I use k here. Sorry about that. But if it actually exceeds max sum, then we know we can't do anything now, right? Because we can't add this to our current sum, because then we'd be breaking the problem's rules and exceeding our current sum to this maximum sum. So if that's the case, we immediately want to break from our loop. We can't add any more elements because since we're actually looping through the values in this range, any element after this is going to be greater than it because we're going in a sequential ascending order from 1 up until n. Right, we're going from 1 to 2 to 3 to 4 to 5 to 6, which is why this for loop is so useful. We're going at the smallest value possible at each step incrementally. Right, that's the whole definition of why we're using this for loop here. We want to use the smallest possible integers to maximize the number of integers we use and minimize incrementally the sum that we actually have, so we have the most number of integers without actually increasing or exceeding our current sum to exceed the maximum sum total. Now, if the current sum plus this I is actually exceeding the max sum, we can't add the current element to the current sum, and we have to immediately break because we know if this element plus the current sum of the running sum of the elements, if that exceeds maximum sum, then we don't care about any other elements because all the elements after this are going to be greater than it because this is a for loop in ascending order. So we can immediately break and then return our count, right? Rather, in fact, I actually forgot to initialize that. So I'm going to initialize count to be equal to 0. And count is simply going to keep track the count or the number of elements that we actually use in this range to actually form our current sum that are not in the band. So now, there's one more mistake kind of thing that I'm missing in this problem here. I haven't actually updated my count, nor am I actually incrementing my current sum. So I'm not actually accounting for the fact when I actually add the current element to the current sum, as long as I don't exceed my maximum sum, right? It's always going to be 0, because I'm never updating it. So, if I is not in the band set, if this condition fails, and if I can actually add this to the current sum without actually exceeding the maximum sum input, then I know I want to actually add it and simulate that updation. Right, or that updating, right? So I'm going to actually increment my count by 1 because that indicates that I'm using one more value in this range, and increment my current sum by simply adding it with I, right? Because we already established that even if I add it with I, it's not going to exceed my maximum sum parameter value, right? And this count plus 1, or rather plus equals 1, is simply just incrementing the number of variables or the number of integers in this range, or the count of the number of the numbers that we've actually used by 1. We're using one more element in this range that doesn't exceed the max sum input, and that also isn't in band. So unless I made any syntax errors here, this should be accepted, and this should be a valid solution. Okay, let's see what I did wrong here. Oh, oops, sorry. Looks like I forgot to. Now this should be a valid solution, and now this actually should work. And as you can see, this is just about as efficient as you can get. So, for a quick high-level rundown of how this algorithm actually works, we're simply just converting initially band to be a band set for a quick lookup time to actually avoid any performance issues, because sets and hash maps have constant time lookups. And then, once we initialize the count of the number of integers we actually used to actually return that, and the current running total of all the different elements that we're adding that are minimized to maximize the number of integers that we're using, now let's actually iterate over our integers from 1 to n, right? We're skipping those that are banned and on line 9. If in this current iteration, if the current element that we're looking at in this range, if it's in the band set, then we know we're not allowed to use it. We have to simply continue on to the next iteration because that's the whole definition of that band data structure input. And now we also have to check, well, if adding the current element I to our current sum, if it exceeds the maximum sum input. If it does, then we're not allowed to use it, and we know that all the elements after this iteration are going to be larger than the current element I, and so we immediately have to break. And if that's not the case, if both of these conditions are actually failing, then we know that this is a valid element to add because it's not exceeding the maximum sum and it's not in band. So we can increment the number of integers that we're actually using, the count, by 1, indicating that we've used one more integer in this range that meets the problem's criteria, and we want to increment our current sum of the total elements that we're actually adding or using by the current element I, right? If that's not actually exceeding the maximum sum, and effectively we're just returning count. And effectively, again, we're just stopping when adding the next element actually exceeds k, right? So if you guys enjoyed this solution and learned something new, please consider liking this video. And I almost forgot, for just a quick reiteration here, the time complexity is going to be a big O of n solution, right? N is simply going to be our input n. And the space complexity, as you guys can see here, this is actually a really cool feature, is also going to be big O of n, right? Because we're actually converting this band set into an extra set, right? Band set is going to be a set of band, and n is going to be the length of our band input array. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.